Hey folks, if you're looking at this, which wouldn't surprise me at all, we're doing the salt hydrolysis worksheet. Salt hydrolysis is one of those advanced topics. It's rather complicated, so it wouldn't surprise me if you have to look at this. Right? We're reacting each of the following ions with water. So you could think about that we threw in something like a salt, which was NaC2H3O2, and we threw that into water. Right, and it breaks up into a positive and negative ion. The ion that we care about is this one because it's part of a weak acid. Right? Notice it's negative, so it's going to tend to grab a positive, so it's going to tend to grab an H, C2H3O2, and it's going to produce that as a compound. Well, where does it get the H from? Well, remember in water, which is H2O, or sometimes written as HOH, right? Water dissociates. So some of the water, remember we had a pH of 7, which means you have 1 times 10 to the minus 7th moles of hydrogen ions in a mole of water, moles per liter in a liter of water. So, and a liter of water is a whole lot more than a mole, right? So what we're talking about is you get some H plus ions in there and some OH minus ions in there. Well, if the H plus ions are sucked up by the C2H3O2, the acetate anion, they disappear out of the water, which leaves an imbalance, and there are more OHs in the water than there are H's. So this would become a basic solution. Right. Now, if we look at something like NH4, this is again the one we did in the podcast earlier, right? That NH4 is going to break into NH3 plus an H plus ion. Well, now all of a sudden you can see you've got more H plus ions in the water than you have OH minus ions because you're throwing H plus ions into there because NH4 is dissociating into NH3 and H plus ions. So here you have an acidic solution. Now you could say, well, the H plus ions go and get together with the water. So, and that's often the way it's looked at, so it becomes H3O and it's positive. But either way, it really doesn't matter which way you look at it. You're getting more H pluses in the water, and that's creating an acidic solution. Right? How about F minus? Well, F minus is going to attract an H plus. And this is a weak acid. Hydrofluoric acid's a weak acid. So it is going to leave an excess or an abundance of OH ions in the water. Again, we talked about how it pulls them from here, right? So you're ending up with OH ions in the water, so that would again be a basic solution. All right, how about cyanide? Again, cyanide is negative, so it's going to tend to grab an H plus ion. So it's going to create hydrogen cyanide or hydrocyanic acid in the water, and what it's going to leave behind is OH minuses because it's taking the H pluses out of the water. Remember, you've got HOH, and it dissociates into H and OH, and they're in equal amounts. Well, if you take these and you stick them over here as part of a compound, then you're left with the OHs floating around in the water, so this becomes a basic solution. Okay, now how about this one? Well, it's very complicated, but notice we've got this amine in here, this NH3 business, and it's positive, so it's going to give up a hydrogen. So it is going to become CH3 NH2 plus hydrogen. Okay, so when that hydrogen comes off, it is simply a proton. This is a proton donor, so all of a sudden there are excess H plus ions running around in the water, so that makes it an acid. Right, now again, you can write it this way. You could write it as CH3 NH3 plus water gives you CH3 NH2 plus H3O plus, if that's the way you wanted to write it. Either way is fine. So long as you understand the concept, I'm happy. All right, we have over here a nitrite ion. It has a negative charge, which means it is going to tend to attract an H plus ion. So again, in water you have H plus and OH. The NO2 attracts the H plus, So you end up with HNO2 as a compound in the water, which leaves the OH ions just floating around. So this would be a basic solution. All right, how about this one? Notice that nitrogen again, probably going to throw away that hydrogen. It's positively charged, so that makes sense. The hydrogen comes off, so it becomes C5, H5, N, and you get an H plus ion sitting on the outside, so that is clearly going to be acidic. Okay, again, you can write it the way we just did, C5, H5, NH plus water gives H3O with positive charge plus C5, H5, N. All right, now how about this negative one? This one is an exception to the positive and negative rule, because typically if it's negative, it's going to gain a hydrogen, right? In this case, it's going to do the reverse. In this case, because this is actually, if you think of the PO4, you should be familiar with that as phosphate. And remember, it takes on a -3 charge. So what this is going to do is this is actually going to give up one of its hydrogens. All right. So when it breaks apart, it has a negative charge, and we stick it in the water. All right. What it's going to do is it is going to give up a hydrogen, and it's going to become HPO4 with a 2- charge. So you now have a more acidic solution, which eventually, if you want to write it this way, is H3O positive, if you want to put both of those together. Right? But bottom line is, it is producing something that is more positive. It will continue to do that until you get to PO4 with a -3 charge. Right? So, anyway, it's one of those exceptions. We're not going to test you on that, but just wanted you to be aware that there are exceptions. Okay? That's it, folks. You are done. If you have questions, please see us in class. We'll be happy to help. Take care. Congratulations. You're done with another unit.